2. Oh, Saturday morning, you can tune in and hear from the founder of CryptoHack. You want to hear about his cryptography platform, which is wonderful. So check that out if you like. It's worth extra credit if you do it, like any other training event. And here we are. Oh, the midterm grades are up on Canvas. We're at the middle of the term, so I calculated them and put them there. I just took all the quizzes and discussions and homework so far and turned it into a number. People who have been doing extra credit are, of course, getting an A, but there are some lower grades for people who haven't done extra credit. Anyway, so today's enterprise services. And I've got the slides. I think I have to open them up again. All right. There we go. All right. And I'm following your book, so the actual description of these enterprise services is probably a little bit out of date. I've updated what little I can, but these are expensive corporate things I don't have access to. So if students want to chime in with updated information from the companies you work at or something, that would be helpful. I'm learning a little bit through my corporate consulting now, but mostly these expensive products, I never get a chance to play with them because I've only worked at small business and places that use free stuff. Anyway, DHCP and DNS, everybody uses that. DHCP is what assigns IP addresses to devices when you boot them up. Typically, you do not put it on servers because you want servers to always have a fixed address, but you use it for clients. So you can pick up your laptop and move it to a different room and reboot it and get an appropriate IP address for wherever you are. It goes over UDP 67 and 68, and you get what's called a DHCP lease. When you boot up your machine and connect, you get an IP address, and it is your IP address for a period of time, typically a few days. And then it expires, and you may renew the same address, or you may get a different address. So if you really want to identify an address, some IP address is, say, infected with malware, you find it in your logs looking in Splunk or something, then you want to know which physical device had that IP address on this day. You need logs to do that. So you can search for a date in the logs to find out which system had that address. And you can also search all dates for a MAC address once you find out which device you want, and you can find all the IP addresses that machine had, so you can check other entries at other times in your log when that machine moved around. Those are both pretty obvious things you would do to try to figure out what's going on with an incident where one machine is doing a bad thing, and you want to follow what did that machine do in other locations, since that machine is doing something bad. So Microsoft DHCP can be put on a Windows server. All you have to do is turn it on in server settings. And if you do, it'll save a log with the usual stuff, IP address and MAC address and time. That's really all you need, a few other things. But the problem is it'll only retain the logs for 1 week by default. And like most systems, the time is local time, not universal time, UTC, which we've talked about before. To coordinate logs from many devices, it's much better to convert the times to UTC. But most logs do not start out that way, and you have to convert them somewhere else, like inside Splunk. All right, ISC is the DHCP server that was used in the early days, developed for Unix and Linux. The Microsoft product came around later, and it's very common. It logs using syslog, which is the standard service you use to log things on Windows, and it uses facility number 23. You know, Microsoft has these categories of logs like security and application and stuff, and then it has this event ID. Unix uses this thing called syslog facility number to categorize logs into categories, and local 7, also known as facility number 23, is the place where automated address systems go, like DHCP. And routers too. So anyway, that's where it goes. And the syslog is recorded on the local machine in a syslog file, and it's often forwarded to other things, log aggregators like Splunk. So the log will just be a simple line like anything else. There's a DHCP acknowledgement from this address to that MAC address, and here's an inform. There's like 4 steps to DHCP. You request an address. There's 4 things back and forth, like acknowledgement and inform, and there's a few other request types. Discover and offer. Discover and offer, acknowledgement, inform are the 4 things. There's a 4-way handshake to get a DHCP address. And so you see various records of these things. And this is why, Splunk is so great, because everybody's log's a little different. They have different fields, they have them in different orders, and it helps to have some kind of SIEM system that will try to reorganize it to make it easy to do something like search for a MAC address, even though the MAC address is formatted a little differently in each log. Then there's DNS, which we talked about a lot. Converts alphabetic domain names to numerical IP addresses. You can't get anywhere without doing this. And unless you're using the newer DNS over HTTPS system, these things are sent unencrypted over the network, and they're a very good way to keep track of what everybody's doing, because you have a nice simple record of where they went and when they went there. So if you want to see who is going to inappropriate websites or command and control servers or anything, it's a very nice place to see it. All right. Bind is the DNS server, the open source one that most people use. Been around forever, and it doesn't log by default, but you can turn it on. And if you do, it will log things like this. Here's a query looking for that domain. Give it this reply coming from that server, so you know who asked for it. And there should be a timestamp somewhere, although I'm not seeing one here. Anyway, Microsoft has a DNS server too, and you can control the logging with a graphical display, of course, what you want to log. And then you'll have things down here. The DNS server is started, and here's a query looking for yourname.com, looking for 4chan.com, and so on. Here's got a timestamp and a record of who's looking for what. It's pretty simple. And you can, of course, do this without having the server software itself do it. For example, if you're using an off-site cloud service like OpenDNS, you're using their DNS server like 208.67.222.222, so you don't have access to those server logs, but you could log the traffic going to that server. And any TCP dump or other things, you write Python to do this, you can just grab the DNS packets off the wire and log them. That's another way to do it. It amounts to essentially the same thing. All right, let's take a look at a Kahoot. I've got them here. Favorites, 152.10a. There we go. Find name first. Yeah. That's sort of Unix command line type search. Well, if we don't get any more players, the competition will be somewhat weak. I'll give it a few more seconds. These folks might just get an easy competition today. Looks that way. All right, we will charge ahead regardless. All right, so which one changes IP addresses frequently? Right, DHCP gives you a new address every time you reboot, typically. All right. Or DHCP, I should say, pardon me. Which one runs on UDP 68? That's also DHCP, good. The crazy one here is WINS. WINS is an old alternative to DNS, not really used much anymore, but it's around as like a legacy protocol still present on Windows systems. All right, which one retains logs for a week? Your Microsoft DHCP server. All right. And which one came from UC Berkeley? Berkeley, Internet Name Daemon. All right. So, find. Oh, by the way, J, I know who that is. And that, I know who that is. Find will have to tell me who they are if they want their points, but they may not care. All right, so let's go back to the slides. All right, so here's some more enterprise. My command worked. Okay, I see a name. Go to name for the find. All right. Good. I've got your name. Good. Good. All right, so here's some enterprise management applications, and these are ones I've never used personally, but I know this is a big deal if you run an enterprise. You want to keep a log of who's using what, for example, to make sure you have paid for the license and things like that. So Landesk and Semantic Altiris are two of the enterprise type products used for this purpose. This is software license monitoring, so it keeps track of every time you execute every application. So it knows who ran it and when they ran it, and so exactly what they ran, which is handy if you have to keep a record, make sure you've really paid for all the copies of Photoshop and Microsoft Word you're running. And of course, also if people are running malware or anything, it's useful information. So the typical thing an attacker will do is they will find some way in, like phishing, and they will find some way to run some kind of code on a machine, and then they will upload hacking tools, typically zipped, unzip them, run them, do things like steal password hashes, and then delete them and move on. So you'll typically find tools that were strange tools that really don't belong there, run just once and then deleted, and so that would be pretty easy to spot in the log. So the log for this this product, Landesk, is in the registry. I don't know why they put it there instead of a text file, but they put the log in the registry, and so each application has a separate key, and that contains how many times it has run, when it was first run, who's been running it, and so on. Information about who's been running that application, and so you can go there and find if there are any funny applications or applications that were only run once or other suspicious things. All right, you can also export the registry with various tools. You can export registry hives with forensic tools. We talked about that before. You could now query those registry hives if you wanted to with Velociraptor. And there's various tools that would be able to parse it. So you look for things that have not been run very many times, that are run from strange places, like from the recycle bin or anything, instead of from some reasonable location, like somewhere in program files for properly installed programs. Look for things that are rarely used, and a bunch of them are all used in a short time period, like command line tools that normal users don't use, like @ to schedule a task, and net to observe network traffic, or Net1, which is a Microsoft version of Net that was written specifically to handle the Y2K problem back around the year 2000, and it's still around, but it's not something a normal person would use. These are the kind of things that indicate somebody's using the Microsoft utilities for scanning your local network, things like that. Look for suspicious usernames, user accounts that haven't run very many apps, therefore they're not really an employee working, accounts that shouldn't be on there, administrator accounts, suspicious activities, not normal business. Executables that have been deleted. Now an installer, you download something, you run the installer once and then you delete it, but anything else, you don't normally delete it after running it, you leave it on there, like Microsoft Word, so that's another mark of a suspicious thing. And then you have another product that does essentially the same thing, Semantic Altiris. This will do application metering, which records the same thing, execution history of apps. So it's got a plain text file keeping track of, how much has this app been used, and if so, by who. So you look again for executables without version information. That's suspicious. Any proper executable should have a version information and be keeping track of when it's been updated. CrowdStrike, I've never used CrowdStrike. As far as I know, they don't have a free version. If they did, I would cheerfully put it in the projects. They have a very good reputation, though. I mean, they're a very serious company. A lot of people use their products. Them and FireEye are very famous to make a pile of money. A lot of enterprise customers use it, but I can't gain any experience because they don't have any free version, as far as I can tell. So I don't have any personal experience with it. But they're out there. Anyway, so look for things that are too small. Malware is usually very small because it doesn't really have all the features of commercial products. And then there's antivirus. Now they call it Endpoint Protection. And so here's, Semantic Endpoint Protection, McAfee, and Trend are some of the big players here. So generally what they do is they detect only known executables. They typically have some heuristic detection where they try to detect malicious behavior without matching a signature, but in practice that almost never works. So the only thing they really do is detect known executables, or a known fingerprint. And all right, they will keep logs of what they do, what they find, but you can't, just because you scan something with antivirus and it doesn't find anything does not mean it's clean. There's a bunch of ways to avoid that, the simplest one being living off the land. You can use built-in Windows tools to perform attacks, and then there's no malware, there's nothing for antivirus to find. So antivirus will often delete the files that it thinks are suspicious, but you don't want that. In a corporate setting, what you want to do is you want it to quarantine the files it thinks are malicious. It will modify them so they can't run anymore and save a copy so you can analyze it later, because you want to have samples to analyze the malware that's on there. So you set it to quarantine files, and each one of them has their own way to modify the file and hide it somewhere so that it cannot be accidentally run by the user anymore. All right, so attackers will often use password-protected archives. And antivirus, of course, can't open them because it doesn't know the password. So you might find a log saying, I was unable to scan this archive because I couldn't open it. And that would be a sign. You probably don't want anybody using password-protected archives at your company, except for some special cases, in which case you should know about it. So that would be a suspicious activity. So Semantic has extensive logs and also puts events in the event log, but it puts in its own logs, it uses some goofy proprietary timestamp, which is kind of screwy. Instead of just having month, year, and date, it has some silly system, so you need to translate it back. Anyway, so the quarantines files gives them a VBN quarantine. There's two files, metadata and the encoded copy of the file. And it used to just XOR the file with 5A. Now it does something a little bit different, but it just scrambles the bytes in a way so that file can't be run. They give you a tool that can extract the files from quarantine so you can recreate the original file. And you can do that on on a copy of the quarantine machine, or you can use, there's an open source Python tool that attempts to reconstruct it, but it doesn't always work. All right. Then there's McAfee. John McAfee came to hate the company that had his name. Said it was the worst product in the world. He died recently, but he was a notorious crazy lunatic doing a lot of funny things in security before that. Anyway, McAfee product continues, although no longer with the founder, who was turned against it. And so it keeps a lot of logs. It logs applications that try to terminate it, buffer overflows, files scanned on access, scheduled scans, updates, keeps log of all sorts of things that the antivirus is doing, as it should. And so on access scan shows you the files that were quarantined or deleted with the name of the threat. And then the quarantined files have a BUP extension with metadata in details, and the quarantined file in file O, just like the other product, it's XORed it with a key and then compressed it, so it's just scrambled in a way that it can't be accidentally run, but it's pretty easy to recover the original file. And the metadata, here's an example of the metadata that shows you the detection name. This is a password cracking program called pwdump. Here's the time when it was detected, and here's the original name and path where it was. So that's useful information. All right. I think it's hay fever. I was noted at certain times a day I sneeze a lot. Anyway, Trend also stores logs with the name of the thing. Here's a password dump being found, same thing, with a date and the signature name and what action it took. And again, it quarantines them, modifying them, and gives you a decoder so you can reconstruct them if you want. All right. And like I say, there's a lot of other products like Carbon Black. that a lot of people use, and I just don't have any information about it, but it would be nice to. You know, if they would update this book and have the more modern, popular products, it'd be nice to know. But you can see they all do pretty much the same thing. So these are representative of the class. And if any of those tools would give like a free educational version, I would happily write projects and have my students practicing with them. That would be awesome. But if they're only going to sell it for thousands of bucks, I can't really practice with it. Well, there we go. One person seems a little silly. I'll wait a few more seconds, see if we can get up to 3 anyway. Well, we will proceed anyway. That way people can view the questions. Here comes somebody. Good. We'll see if there's anybody else coming. Although I bet this is the same person. All right. All right, which one had the unusual 6-byte timestamp? That was semantic. Norton semantic. All right. All right, execution logs in the registry. That was Landesk. All right. And BUP files. And that's McAfee. All right. And which one of these is not suspicious? Installers are run once and then discarded. All the rest of these are pretty suspicious. Executables without version information, clearly they can't be updated. You can't keep track of which version you're running, so that's not a proper commercial product. And two files with the same MD5 but different names is screwy. Why would you make a second copy of the same file that's bit for bit exactly the same? That's suspicious. All right. Anyway, I think these are the same people. I'm assuming C is the person who called themselves Find last time. That seems likely. So I'm going with that until other information is presented to me. All right. We will charge ahead. All right, then web servers. Apache is the free open source web server, the main one I always use, of course, because I primarily like to do things on Linux, which is where you typically do it. Anyway, all browsers, you send HTTP requests over the network, and then you send a GET to retrieve a page or a POST to send up data like username or password, and there are a few other methods, but those are the main ones. And so you typically listen on port 80 for the old unencrypted HTTP, which is really not that common anymore. Pretty much everybody uses HTTPS for almost everything these days to make everything encrypted and safer, and that's on port 443. Many people run multiple websites on the same server. because one server can really even a fairly modest server can handle thousands of requests per second, so you can store a lot of websites, and then it will just look at the request to decide which website to show you. But if one of them has a weakness and somebody can get a shell on the host, they may be able to affect all the websites. And this seems to happen pretty often to GoDaddy. I hear a lot about this. One GoDaddy site will get hacked and it will affect the others, although I might be getting a little better now. But those big hosting platforms, of course, especially the cheap ones, are kind of insecure and unsanitary. And I think they're a lot better than they used to be, though. So there's log files on the web server, which if you're using a service like GoDaddy, you probably won't be able to get to them. But if you're running your own web server, then you can. And they're just typically stored in plain text, and you record, the client, what they requested, and whether they got it. So if on the log files, these are searches you would typically do. Request during a time frame, when you suspect a bad thing is happening, from other evidence, of course. Request to a certain IP address or URL, or given a user agent string. And this is what we've been doing in Splunk. You've been searching logs for criteria like this. Load balancing is an issue at large companies like Google and Yahoo. They have many servers, and there's a load balancer in front of it. And so each request goes to a different server. And so you don't really know which server you are going to, and you don't really know which log your data would be in. So that's kind of an issue. And the log will have the IP to load balancer, not the client. So there's issues there. One way people handle this is they configure the load balancer to add an extra header called xforwarder4, so it records the real IP address of the server it went to for logging. And if you use Cloudflare, which is a free reverse proxy, they have the same ability. You can configure your web server to record useful information so you can track things back. And so attackers often upload on files like PHP shells or alter files to deface pages, and often upload obfuscated PHP that's scrambled like this. You have these long random letters and numbers. So what they did here is they defined a variable that's this long alphabet, and then they picked letters, the 43rd letter followed by the 20th letter followed by the 21st letter. So this is spelling out a command, and it's obfuscated so it's hard to read. And the point is not only to make it hard for humans to read it, but make it so automated scanners cannot recognize the malicious activity here. When I was trying to repair a hacked server on GoDaddy, they wouldn't let me have a command shell because you have to pay more money for that. So I tried uploading a PHP shell, and it deleted it because I just took the world's simplest PHP shell, and all I had to do was add one character to it, like a space, and then it would no longer delete it. So it had some kind of web-based malware detection that was incredibly weak. And this is what you do. You obfuscate it like this, and then the web-based detection of malicious files won't find it. So Apache is the free open source web server. You can run it on Windows, but most of the time people run it on Linux. It's got configuration files, and you can also have htaccess files restricting access to certain directories. And you have log files, access log and error log. And so you can put this in the configuration file if you want to have these xforwarded4 headers, and you'll just see here's somebody on a certain date and time performing a get to try to download this text file, and here's the user agent for the request. So there's a record of somebody's access. The website typically lives in varlog HTML, but it can be put somewhere else. And if you look in the configuration files, you'll find these root parameters telling you where the web page really is. And Microsoft's IIS is the Windows version of the same thing. You can install it turn it on in any server version of Windows and Server Manager. And then it's got an XML file, application host config, which has information like the path to the thing, which is typically inetpub www-root. That's the default location of websites. And again, you can move it somewhere else if you like. And all right, it also has log files, and you can specify where they're going to go. And the log files have a date, and they're plain text, but they're encoded with UTF-8 because Microsoft is an international operating system and allows you to use non-English characters. So here's a log file. There's some header fields, And then it's got query, export. So here's telling you this is post going to some AJAX web message ASPX script in Microsoft's application server pages. I think they call this their imitation of PHP. And then you have the user agent here. So it just records who came in, from what IP address, and what file they accessed. And then there's database servers, which are huge, of course, where you store usernames, passwords, credit card numbers, purchases, and pretty much everything these days ends up in a database. And these are the big ones: Microsoft SQL, MySQL, or Oracle. Those are the three main databases. So if you have connection logs, they'll record the IP address. Error logs will show you things that went wrong. And query logs would be nice, that will record all the queries that have been exercised on the server. But the problem is that is such a large amount of data that it slows down the database server, and almost everybody turns these off by default. So you don't want to leave them on all the time. It would be nice for a forensic examiner trying to analyze a hack, but it would slow down performance of the web server, and nobody's generally willing to pay for that. So DB is often, the database is typically huge, stored in many files on some kind of disk array. So it's not easy to make a copy of that database, and we've talked about this in earlier lectures in the class. It's generally far too difficult to get a complete drive image of the database storage array. What's a lot better is to just execute some kind of query against the database and do a live collection of the data of interest, rather than trying to copy the whole database. So Microsoft SQL is their commercial product, costs a lot of money. There's a free version called SQL Server Express, and you control it with SQL Server Management Studio, and it doesn't log client connections at all. It only logs errors by default. Here's the error log. So here you have a attempt to log in but failed, and here's a login that succeeded, which it does put in the error log. So at least it records logins, which of course are important because then you can detect brute force attacks where somebody makes multiple attempts to log in with different passwords. That's obviously something you would like to know. And logins are not that common, so it's not going to fill up the hard drive and slow down your database too much. It doesn't log queries. You can turn on a thing called a server-side trace, which will record what it's doing, but that will slow down your database quite a bit, so you would only do it temporarily when trying to diagnose a problem. So to preserve your evidence, you could make complete forensic images of the drives, but that's usually huge and horrible. You could copy the DB files itself, but they're locked. In use, you can use the system management server to back up or export the data, and that's a live acquisition, and that's probably a good answer. You can make a backup or export data, and that's not forensically perfect, but it does get you most of the data without slowing down the server or taking it down, and it's usually the sweet spot. MySQL is the free open source product. Oracle bought it, and so the purists of open source community got very upset. They don't want to have Oracle owning anything, so they forked it and made a thing called MariaDB, which is essentially binary compatible with MySQL. Either one is pretty much fine. So it's got a configuration file, and you can specify where the logs go in the configuration file. And so they're in varlog, of course. Where else would they be? And typically only log errors by default for performance. You can turn on more logging, but if you do, that slows it down. And you've got, here's the general logs, so you can just see root connected from this IP address and did a query, select something from CC data. So that's an example of a log of a query on the database. You can acquire the data. You could shut down the whole server and image the hard drive, but if you don't want to do that, which you probably don't, then you could just stop the service and copy the files. But if you don't even want to stop the service, there is a MySQL dump command that will back it up without stopping the service, just like there was for Microsoft SQL, and then you're getting the data without forensic perfection, but you're not having to stop the server for it, which is usually what you want. And then there's Oracle. Oracle is extremely expensive. It's used by big companies, insurance companies, and government a lot. It was generally considered much more secure than the other products until about 8 years ago, when the DEF CON people exposed a whole bunch of flaws in Oracle and terrified everybody, and said that it's really not better than the others. There's another form of SQL injection on Oracle and stuff. But anyway, it's used by big companies. You can get special Oracle certifications, and then you're supposed to be able to walk into high-paying jobs, because it's pretty hard to manage, pretty confusing. Anyway, it does log each connection. But it doesn't log every query, but it logs who connects, and it logs alerts by default, which is where you'll find dumps and traces if you turn them on, but they aren't on by default. And so the listener.log will just show that someone connected to it from an IP address. You can turn on auditing, which will record more information but slow it down, just like all of them. All right, so let's take a look at 10C, and I've got some bunch of new projects to show you after this. But let's take a look at the last Kahoot. I made a whole bunch more threat intelligence projects, which I'm very happy with, which I'm planning to demonstrate. We'll see if the mysterious C wants to join us or not. Ah, all right. I'll give it a few seconds to see if anyone else is going to join us, but I think it's just the three of you tonight. You guys don't exploit the opportunity to get free points. This is how I won the black badge at DEF CON. I found a contest like this that very few other people were competing in. Anyway, all right. All right, free open source software. That's Apache. All right. Which one conceals the IP addresses from the server logs? That's load balancers. All right. Free but not open source. SQL Server Express. Microsoft's Express stuff is their free version of their proprietary product, but you don't get the source. All right, a tool used to manage a database server. SMSS, it's SQL Server Management System or something like that. All right. And which one logs connections by default? All right, and that's Oracle. All right, so I think there's no real suspense about who wins in a contest like this. All right.